Hi everyone, my name is Arash. I'm a PhD student at the University of Arizona. I've been working with Kari on designing and implementation of 100 gigabit Ethernet on VCU 118 and VCU 128 evaluation boards. So during last couple of days, we had different talks on different examples of observatory sites and their backends. And one noticeable thing about their backend was they were using either one or multiple 10 gigabit per second or 40 gigabit per second ports. However, we need more bandwidth and we need more data to process. So the next generation of radio telescopes and in the result, next generation of event horizon telescope are aiming at 100 gigabit per second ports. So for this project, we are using VCU 118 in the left, which has two 100 gigabit per second ports, which in total will give us 200 gigabit per second. And in the right, we are implementing this project on VCU 128, which has four 100 gigabit per second ports, in which in total can provide you with 400 gigabit of data per second. Our design has 4 steps. Data flow in our design has 4 steps. The data comes from ADC, it will be processed, and it will be prepared for transmission, and then it will be put on the cable. So I have put steps 1 and 2 in the gray block here, which we are not going to talk today. And today I'm going to talk about packetization and transmission of the data. Each part of the design has a system controller so that you can configure the system. So the data that we want to transmit first is being put in the FIFO, or first in, first out buffer. As the data is being put in the buffer, the packetizer will read the data from the buffer. And it will wrap it in, first will wrap it in VDIF header. Why VDIF? Because VDIF is commonly used in VLBI applications and also contains very useful information like number of channels, station ID, and many astronomy software really like this extension. And also this packetizer block in our design will wrap the data in UDP, IP version 4, and Ethernet headers, there are standards, and then it will interact with the IP that Xilinx is providing to transmit the data. So I told you about this FIFO, this buffer, and packetization. We have 2 channels in our design, Packetizer 1 and Packetizer 2. Each packetizer will produce 32 gigabits per second of data. So in the end, we expect to get at least 64 gigabit per second of data. We can have as many packetizers as we want. They are very modular, and each operate independently. In our design, blocks in the system talk to each other through AXI-bus. You can, and also you can talk to there's a system controller. You can talk to the system controller using your C++ or Python code through a UART communication. And this system controller will configure registers, will talk to each packetizer, and also will activate or deactivate fibers, optical fibers. So, and by saying configuration registers, like IPs, UDP IPs, time epochs, different registers that we need to have in our system, and even stop or start data transmission. We have developed a C++ program that monitors the data. I've used XLib library to plot the data. This application supports multi-threading, so each thread will listen for data on its own thread, and also can communicate with the FPGA board through UART. You can see in this plot, you can see ramps. These ramps are some samples generated by FPGA, just as an example. We don't have the ADC yet, so we are generating the data, some ramps on FPGA. So what about the current status of the system? We learned about this OSI model in a JSON talk, and the FIFO part is done. Packetizer can wrap the data in VDIF, UDP, IP version 4, and Ethernet headers. AXI and UART and I2C communications are implemented. And we have the monitoring system, C++ monitoring application. So right now we are testing this system in the lab. So far, we have got 68 gigabit per second, and it's with an optimal speed. Of 68 gigabit per second with packet size of 1480 bytes each side of the packets. So we are working on we are testing jumbo packets, and we are working on optical fibers. We are going to test optical fibers and I2C soon. Also, I'm always in the lab trying to find a way to verify the data, so that the ramps that we are generating are the correct data. Are we receiving the right data on the computer side? So, does this design support full bandwidth? Sure, it does. Does it support macro blades that Casper is moving toward? Yes, it does. However, this design only supports transmitting. We have not implemented receiving. And the data first is encapsulated in VDIF packets. So I'm telling this because we want to discuss about porting this design to Casper. So do we need to turn off VDIF wrapped observation, or we don't? So this is something that we need to discuss. Also, Benjamin had worked on another design that is very general and can transmit and receive. However, we handle the dropped packets differently. So when we want to drop a few bytes, when there are a few bytes missing, our design will drop the whole packet. This is very inefficient, but we know where the data is being dropped. So in the other design, a few bytes are dropped, but we don't know where they are. Also, resource utilization. So since this is very application specific, our design uses very, very efficient, very optimal resources. So do we want to use a more general resources, a design that uses more transistors on the gate, on the FPGA? So this is something else again that we need to discuss about. Thank you. Questions? Yes.
So, VDIF, how come you didn't encapsulate it with BTP, which is the packet serial number on top, or do you have plans on that? And when you were talking about thread IDs, was the Packetizer a single thread ID within the VDIF frame, or was it the thread ID that you were using for the C++, and it's different? So how many thread IDs do you support?
All right. So currently we are only doing VDIF. The reason is that, so let me go back here. So for this design so far, we only have VDIF. I'm not sure about future plan if I want to support any other extensions. But
I'll just let you know. So BTP is simply putting a 64-bit packet serial number on top, so you can guarantee order.
Okay.
You're transferring over a long path. It's a very small thing, but it's a good thing to have, especially when you start receiving it on the other side, which you do with those payloads if they get dropped.
So we do have a register in the VDIF, on the VDIF header, I think on exactly thread ID, that we increment for each packet. So on the receiver side, we receive, there's like a increment, there's a register that we increment to verify the data for this design, just for verification. Yeah, but sure, that's a great idea. Thanks.
Time for one more question.
I didn't quite get what you meant by drop packets. Are you talking about packet fragmentation?
So,
Say you form a UDP packet, you only encapsulate that in the header when you construct the packet.
so currently, Xilinx provides up to Ethernet layer by their IP block. So we only transmit data when the IP is receiving, when the IP is ready to transmit data, and the data is constantly coming. So if this block cannot receive any data to transmit, what should happen to that incoming data? So currently we drop the whole packet. So it's in the FPGA. It's not even before creating before transmitting the UDP.
I know you said this was the last question. This is a leading question. I wanted to ask Ben and Arash if they would be willing to run a working group,
Okay.
a splinter working group, on one or more of the afternoons.
Sure.
And if the two of you can announce that, or you can talk to me and we'll book a room and set a time, and then I'll announce it when the working groups are happening. And people like Chet, who is a VLBI recording expert,
Great.
can come along and explore in greater depth
Wonderful.
packet formats for VLBI and so forth, which is what your interface
Sure.
is, and also try to work together with Ben to come up with a consolidated Casper solution as well.
Awesome.
I just want to know,
Yeah.
where will the demos be? Are they going to be in the tutorial room?
So, I was thinking maybe in the tutorials room. We can set up a system in tutorials room so there can be demos there.
Will it be today or tomorrow? Or?
I think let's just say that I will work with them, and I'm going to
Yeah.
make an announcement about working groups. I asked the girl, Brian, I said, you've got to keep the time, and here I go. Sabotage again.
All right.
Okay, thanks very much.
Thanks for asking.
Just 1 minute. So before I just sit, I want to take a minute to say a few words in a tribute to my former advisor, Dr. Richard Pistache, who passed away last week. And this is a Casper 2017 at Caltech, and me and him, and he's giving a talk. So I just wanted to say that he was a great advisor, and he was actually my first advisor radio astronomy advisor who hired me at Green Bank Observatory at NRAO in West Virginia. Thank you.